Venus, the second planet from the Sun, is nearly identical to Earth in size and gravity. So similar, in fact, that scientists often call it Earth's twin. But that's where the resemblance ends. Venus is the hottest planet in our solar system, with surface temperature soaring beyond 460 degrees Celsius, hot enough to melt lead, while Earth remains at a very mild temperature of 15 degrees Celsius. Beneath its glowing clouds lies the closest thing to hell we know, a world wrapped in boiling heat, crushing pressure, and clouds of sulfuric acid. It earns the title of the most hostile environment of any planet in our solar system. Despite Venus being a hellish world, from Earth, it looks very beautiful, and is the second brightest object in the night sky after the Moon. But if you were to stand on that surface, you wouldn't just burn, you would be crushed. The atmosphere is 92 times heavier than Earth's. Being on the Venetian surface is equivalent to being 1 kilometer beneath the ocean. But here is the burning question. If they were born as twins, what invisible force sent one to paradise and the other to hell? To find the answer, we have to examine two very different scenarios, two possible paths the planet may have taken early in its life. If we want to know whether Venus was once habitable, we have to look back to how the planet formed and cooled. In the first possible history, known as the Blue Venus hypothesis, everything starts out surprisingly well. For a long time, scientists believed that Earth's water arrived late, delivered by occasional impacts from water-rich asteroids. But newer research suggests a different picture. Early in the Sun's life, the inner solar system may have been surrounded by a thick disk of water vapor. As Earth and Venus formed, both planets pulled in huge amounts of this water, possibly enough to create global oceans in a relatively short time. In this scenario, Venus may actually have cooled before Earth did. The young Sun was about 30% dimmer than it is today, and Venus's position placed it in a comfortable temperature range. At the same time, Earth may still have been cold and icy. What kept Venus stable was the same process that helps regulate Earth's climate today. Rainfall would slowly react with surface rocks, removing carbon dioxide from the atmosphere and locking it into the planet's crust. When temperatures rose, this process sped up. When temperatures fell, it slowed down. This natural feedback helped keep the planet from overheating. If this model is correct, Venus could have maintained shallow oceans and mild temperatures for up to 3 billion years. In that case, the hellscape we see today wasn't inevitable. It was the result of a climate system that eventually broke down. But there's another possibility. What if Venus never cooled down at all? This idea is known as the born hot hypothesis. In this version of Venus's history, being closer to the Sun made all the difference. While Earth's surface cooled and solidified relatively quickly, Venus may have stayed molten for tens of millions of years. Instead of forming oceans, any water on Venus remained trapped in the atmosphere as superheated steam. That steam acted like a thick insulating layer, trapping heat and preventing the planet from cooling. Without cooling, rain couldn't form, and without rain, there was no way for water to collect on the surface. This leads to one of the biggest clues scientists look for today, what's known as the oxygen problem. If Venus once had large oceans that later evaporated, sunlight would have broken those water molecules apart. The lightweight hydrogen would have escaped into space, leaving behind enormous amounts of oxygen. But when we study Venus now, that oxygen is missing. On Earth, oxygen is a sign of life. On Venus, its absence tells a different story. To remove that much oxygen, the planet would have needed extreme and constant volcanic activity to lock it away in rocks over billions of years. The problem is, the evidence doesn't support that level of volcanism. Measurements of gases like argon suggest Venus simply wasn't that active for long enough. Which leads to an uncomfortable conclusion. The simplest explanation may be that Venus never had vast oceans in the first place. In this timeline, Venus wasn't a world that lost its water. It was a planet that was born almost dry. No matter which story you believe, Whether Venus began as a water-rich world or a hot, dry one, both paths lead to the same turning point. At some stage, Venus stopped behaving like Earth. On Earth, the surface is constantly moving. Large plates slowly shift, sink, and recycle material back into the planet's interior. This motion helps regulate carbon dioxide by locking it away inside rocks and releasing it gradually through volcanoes. Water plays a key role in keeping this process running. On Venus, that process appears to have slowed, and then stopped. As the planet grew hotter, its water was lost to the atmosphere and eventually to space. Without water, the surface became rigid. Instead of moving plates, Venus developed a single, solid outer shell that no longer recycled carbon. With no way to store carbon inside the planet, carbon dioxide released by volcanoes built up in the atmosphere. Temperatures rose. Pressure increased. The planet entered a long-term runaway greenhouse state. Then, something dramatic happened. Sometime between 300 and 700 million years ago, Venus appears to have undergone a global resurfacing event. Much of the planet's surface was flooded with lava in a relatively short geological period. Older features were buried, leaving Venus with one of the youngest surfaces in the solar system. This wasn't normal plate tectonics. It was more like the planet releasing heat all at once after storing it for hundreds of millions of years beneath a rigid crust. The atmosphere still carries clues from this earlier era. Venus has about 3.5 times more nitrogen than Earth. Models show that this much nitrogen is difficult to explain unless Venus once had a more Earth-like surface system that operated for at least 1 billion years before shutting down. In other words, Venus's atmosphere is a record of what the planet used to be, not just what it is now. Whatever path Venus started on, once its surface stopped moving, the outcome became unavoidable. Heat and gas built up, water was lost, and the planet crossed a threshold it could never return from. Even on a planet as extreme as Venus, there may be one place that never fully crossed the line into uninhabitable territory. If life ever began on Venus, back when the surface may have been cooler, it faced a stark choice: adapt or disappear. High above the surface, about 50 kilometers up, conditions change dramatically. The pressure there is almost exactly the same as on Earth, and temperatures hover around 60 degrees Celsius. Harsh, but survivable. This region sits above the crushing heat below and beneath the destructive radiation above. In July 2025, scientists studying Venus announced something unexpected. Using ground-based radio telescopes, the research team didn't just confirm the presence of phosphine, a gas that had already stirred controversy. They found that it follows a daily cycle, broken down by sunlight during the day, then rebuilt at night by an unknown process. Even more surprising was the tentative detection of ammonia. On Earth, both of these gases are strongly linked to biology. They don't last long unless something is actively producing them. One possible explanation comes from a model proposed by astronomer Sarah Sager and her colleagues. In this scenario, microscopic organisms could survive inside tiny droplets of Venus's clouds. These microbes wouldn't be passive. By producing ammonia, they could reduce the acidity of their immediate surroundings, turning hostile droplets into small pockets where life could persist. Air currents would lift them upward, sunlight would force them into a dormant state, and gravity would eventually pull them back down to denser cloud layers, where they could become active again. This would be a cycle of survival, simple, slow, and remarkably resilient. If this idea is correct, life on Venus wouldn't be a leftover from a better past. It would be something still adapting, still responding, still finding ways to exist in an environment that collapsed long ago. And that makes Venus not just a dead world, but a planet that may still be chemically and possibly biologically alive. We're entering a new era of Venus exploration. For the first time in decades, the planet is no longer being ignored, and in early 2026, we are only months away from something historic. Rocket Lab is preparing to launch Venus Life Finder, the first privately funded mission to another planet. It's a small, focused probe designed to fly through Venus's clouds and look for chemical signs that shouldn't be there unless something is actively producing them. Instead of carrying bulky instruments, this probe uses a simple but powerful idea: certain organic molecules glow when exposed to light. By scanning cloud droplets for that glow, the mission will test whether complex chemistry or something more might be present. Venus Life Finder is only the beginning. In 2031, NASA's Da Vinci mission will plunge directly through the atmosphere, measuring noble gases that preserve Venus's early history and could reveal whether oceans once existed. Veritas will follow, mapping Venus's surface in unprecedented detail and studying ancient highland regions that may be the remnants of a much older world. So why does all of this matter to us? Because Venus shows how fragile a planet's stability can be. Habitability isn't a permanent condition, it's a balance. Change that balance just slightly, and a world can shift from life-friendly to hostile. By studying Venus, we're not just investigating a ruined planet, we're learning where the boundaries are, how close Earth might be to crossing them, and what keeps our own world stable. Venus isn't just Earth's twin gone wrong, it's a warning. And in 2026, we're finally ready to listen. So, what do you think? Was Venus once a habitable world, an ocean planet not so different from Earth? Or was it born too hot, doomed from the very beginning? Share your thoughts in the comments below, and if you enjoyed exploring the mysteries of our solar system, don't forget to like, subscribe, and join us for more journeys into space.